Yeah, so we continue with our track. So next part, we will start with a talk of Christoph Heitz. Yeah, he's a professor at Engineering School of Zurich University of Applied Science. Yeah, stage is yours.
So thank you, Elena. Welcome, everybody. So navigating between philosophy and technical solutionism. I had a hard time this weekend to let's say to give some substance to that, but let's see how it is. Okay. Okay. How now it does not work again. So what is my fault? Here. Okay. Now it works. So. So what is just for introducing myself a bit, what is my background? Originally, so I'm a techie, even though I will speak a bit about philosophy, but I come from a technical perspective. So I come from database decision sciences, so how to make decisions based on data, and I've been involved in that kind of ethical issues around data usage for quite a while, and have since something like 6-7 years, I really focus on algorithmic fairness. I'm also one of the co-founder of the European Workshop on Algorithmic Fairness, and this is maybe now is my sales pitch for today. So the third edition of that will be in July in Mainz. If you want to attend, there's still a few days of time for submitting an extended abstract. This is a workshop that is very interdisciplinary and focused on creating discussions, and so not so much focused on presentation, but on discussion over the disciplinary boundaries. Okay, fairness and bias. You all know what it is, but I still take the liberty to show you a few of those definitions. There is unfortunately not yet a precise definition of that, but we see some keywords here. That is something like unfair. That is something like making decisions, and we will come to that a bit later in a few minutes. What the common things of these definitions are. But what I wanted to start with is there's a background for those systems, and the background is that someone wants to make decisions. Someone builds system to make decisions and to make better decisions than one did before. And this is what you see here is a kind of a common pipeline that you might have. There is something like a prediction model in the core, there is some decision rule applied, and then there's, in the easiest way, a binary decision, yes or no, interesting or not, reasonable or not. When we digged into this question of fairness, we pondered a bit on these two roles that we typically have. One role of a decision maker and one role of a decision subject. And we have seen that in the first presentation already. There's in HR just the HR manager of the one hand side and the applicants on the other side. And they do have a very different perspective on the same system. What we also see is that more often than not, when applying such system in practice, we see some societal issues. And the societal issues appear typically in a state where the decision maker would say, well, problem is solved, thing works, is effective, we can reach our goals. But the thing that we are talking about specifically is then this bias or discrimination or unfairness. From a machine learning perspective, I'm talking now from a techie soul, this sounds a bit weird, and I just want to cite here this part of this important book about fairness and in machine learning. Discussions of discrimination in the context of machine learning can seem odd if you consider that the very point of many machine learning applications is to figure out how to treat different people differently. This is the very point, that is to discriminate between them. And in the HR context, if you focus on the hiring process, of course you want to accept some people and you want to refuse other people. This is exactly what we want. And this is a confusion, a mental confusion that is there in the heads of a lot of machine learners. Hey, what are you talking about? This is why I'm here. But, and they continue in this book, there's something like wrongful discrimination. And then they come up with, let's say, expressions that are similar to what you have seen before. Now, when we talk about bias and fairness, there are some ingredients where most people agree that they are part of the game. The first thing is we compare social groups, or we compare individuals of social groups. So people speak about categories, gender, for example, race, and their age. We started with that before. Second point is we consider outcomes. So it is about what happens with the actions, the activities of this system. And the outcomes are not just this is not a description of the outcome, but it's really focusing of things like privileging, things like disadvantaging. So the background question is there someone disadvantaged? Is there someone of a specific social group disadvantaged? And then what you also see in all those definitions, we're talking about systematic effects. There can be error, there can be random errors. This is not the point. It's not about how is Joe Miller affected compared to Jack Smith, because we know all those systems might have errors and mistakes. But the systematic nature of that, this is what's problematic. Now, the academic fairness research, as far as I have an overview, started somewhere in the mid-2010s, and it started in computer science. It started in particular in the machine learning community. And it started around the question of prediction models. So when you look at the literature, especially in the first papers, we always have this idea of a fair prediction model, of a biased prediction model. After a few years, philosophers became interested in, because this is their home turf, right? So fairness, justice, and that stuff. But still, the discussion was dominated by the computer scientists. And in a very simplified way, the computer science approach is, well, we seem to have a problem with this bias. There is someone complaining about unfairness, and if I look at that, well, this guy might be right. So then let's see what it is. Let's define what fairness is. Let's define how we measure fairness. I mean, this is obviously something that we need to do, otherwise we cannot build systems that are compatible with some kind of fairness requirement. And then let's develop all the technical methods of how to mitigate bias in concrete implementations, in concrete systems. And we got quite a bit of output of that. And let's say the most tangible output maybe, or one of the tangible outputs, is a large number of fairness metrics. And someone in the Q&A spoke about those 21 fairness metrics. In effect, it's much more in the meantime. We also got technical solutions how to build what then people call the fair predictor. So there's quite a bit of substance there. And just to give you an indication, this is a part of the zoo of the fairness metrics, and you don't need to look into those questions. The point here is each metric is defined by something that can be mathematically well formulated, can be measured in a specific application combined with a database. And this is how we speak about fairness. Now, unfortunately, and you probably know that, those fairness metrics contradict each other. So if you are fair with one, you are unfair with the other. And it's not possible, you can even prove that mathematically, to meet all those fairness metrics at the same time. So we have to make a decision here. And this is one of the open questions that is not at all solved in the scientific literature, at least when it comes from computer science. Now, over the year, there has been some discussion about the general way how that works, and this inspired me a bit to the title, solutionism and ethics. So one of the critiques of that computer science approach is, hey, what you're doing is solutionism, and maybe you have heard about this word. This is defined as the belief that technology is the answer to any challenge we face. Also societal challenges, or let's say challenges with our values. This word has been popularized by Evgeny Morozov. He wrote a book in 2013, To Save Everything, Click Here. And in that book he made the case that, hey, are you sure that you are on the right track here, you techies? Questions in that area is, for example, is the issue of social justice really solved by fulfilling a technical fairness criterion? So choose one, fulfill that. Is then anything around unfairness solved? Or isn't this a much more complex question? And can this complex question be really boiled down to a single number? The more you are technically educated, the less you would pose that question. But still, I just last week I had a long discussion with a computer science student who's in this class we were teaching algorithmic fairness, who said, I don't like that with this matrix. How would you even think of this makes sense? At the same time, philosophers raise questions. And there is questions about the applicability of those metrics. They ask, for example, why should a specific outcome be called unfair? Why do you think that this is unfair? They come up with all kinds of examples that are similar to what in this publication had been discussed, and say, okay, but is this still unfair, or is it maybe fair? So what is the difference between fair and unfair, and what does it morally mean to focus on a specific fairness matrix? What does the fairness matrix mean? You know, I mean, if you implement a specific kind of fairness, you want to create something that is expressed in terms of justice. So there is a meaning behind the technical issues, and this is something that's really not well explored. So in a sense, I think this critique is very valid, and I'm happy that I can express that here in a machine learning conference, even though you might not be from the technical field, everybody. But anyway, there's a good reason here. On the other hand, when you speak about algorithms and fair and debiasing constructors, when you want to build something that should be called fair, then we need at least three elements. We need an operationalization of fairness. We need to define technically, mathematically, what we mean by fairness. Let's say a philosophical concept that cannot be operationalized does not allow us to build something. And this is really a problem that in this discussion between philosophers and machine learners that comes up very often. Let's say very good philosophical discussions, but then how should we take that and build something along that? No idea? Okay. We need to measure fairness, and this is a second point. Fairness by design, which is something that we want to have, needs some objective criteria, and we need to determine how fair a system is. And after we have done that, we need some technical solutions for making sure that these criteria are met. This is not trivial, and a lot of good publication, good research has been devoted to developing them. The point is that it is not a solution just to create something that is fair. We need also to create something that is still achieving the decision maker's goal. We still want in HR, we don't want just a fair or a diverse selection. We want to have a selection that creates a good pool of employees, right? So there's something that has to be coupled. So what we'll learn of that is a pure philosophical debate is not enough. A pure technical debate is not enough, but a pure philosophical debate is also not enough. We need to connect that somehow. And in the next slides, I will show you how we try to develop to connect that. And it starts very back in history with the problem, what is fairness? So what is fairness? And fairness is related to equality, as we'll see. Aristotle, a few hundred years before Christ, said equals should be treated equally and unequals unequally. So this is maybe the basic statement about justice and about fairness. And what you see below is a kind of a modern translation from a FAIR AI course about this principle of equality. This has infused quite a bit of the history, of our Western history at least, and one of the outcomes here is discrimination laws. So the legal concept of discrimination basically incorporates the Aristotelian principle. And if you look at the definition of discrimination, then this is a treatment producing disadvantage of individuals with respect to other individuals, that origins from being a member of a social group, a socially salient group, like men or women. This is one thing. But the other thing is what you also find here, a disadvantaging treatment where there is no qualified objective justification. So there seems to be cases where something like a justification can be done. And this is even ingrained in our laws. Not every inequality is illegal. And also not every inequality is morally wrong. So when we try to boil that to the essence, then the basic principle is an equal treatment. We start from that. Avoid unjustified disadvantage of one group. But both philosophy and legislation agree that inequality may be justified. Now, when we want to operationalize that, we need two things. We need a metric for the degree of inequality. So the normative principle behind that is equality, but then we need also a method of accounting for justified inequality. First point, how could we measure disadvantage? And this is something that is also not super explored in the literature, but we are interested in harm, more harm or less benefit for people. And one way of doing that is to use what we call the utility of decision subjects, so the benefit that people get from a specific decision. And concretely, when we want to look at groups, it's something like an average utility of individuals. And then we can compare this utility between or across groups. The justification or justified inequality is a bit more tricky. So we could have, if you have two groups, A equal 1 and A equal 0, then we could just say, well, equal treatment or diversity means the expectation value of utility is the same for both groups. But what if some people deserve more benefit, if it's morally right to give them more benefit? What if some people, only some people deserve a benefit and others not? So in general, the question is, are there moral reasons that justify inequality? And if so, how should we then apply the principle of equality? Here are some philosophical and legal points that can be brought up to give some substance on that. Inequalities are sometimes justified or even required. And philosophers have discussed hundreds of them, but the three main reasons that they bring forth is merit, responsibility, and need. So higher need leads to a higher entitlement to benefit. So should be more, people with a higher need should get more benefit. People with a higher merit should get more benefit. And depending on the use case, you typically would ponder on one of them. And then the legal stance is actually that we have something like a qualified objective justification, which is a well-defined legal term that I don't want to explain right now. So this can be done, formalized actually. This was something that we try to develop. If you follow up this idea, and if you have cases that some inequality is justified, basically in most cases this is the case, then this equality principle of justice is to be applied to unjustified inequality only. So we want to, there's a justified inequality, there's an unjustified inequality, and we can distinguish about that. So, and thank you. And the one way of doing that is to introduce a relatively new concept. So this is a concept that was introduced by a philosopher, Michele Leu, who happens to be a part of our research group as well. The concept of justifier, and he says there are some features of people who tell us whether or not they have or how high their moral claim to a benefit is, and we need to take that into account. So at the bottom you see kind of let's say a bit more complex equation that states formally this equality principle, but the basic idea is with that concept we can implement what we think is an unjustified inequality versus justified inequality. What we learn from that is that when we speak about how to measure fairness, then we need to define three things, at least. We need to define how we measure disadvantage. We need to define what groups we are considering. So this is, and this is a definition. This is not something that, let's say, can be calculated. And we need to define what is justified and what is unjustified inequality, so something about a justifier. And when we take those three elements together, and this is the interesting result of our research, when you take those three things together, then we get an explicit expression of this general equality principle, and this exactly is the fairness criterion. And what we have seen and also shown is that all classical fairness criteria, the ones that you may have seen at the slide before and the 50 others, can be expressed in this form. And they differ by different choices of how we measure utility and how we measure or how we define justifier. So what we would say is justified inequality. In a bit more technical framework, this comes like here. So if you are familiar with fairness metrics, those are the most popular ones, and then you see here the choices for a utility function and a justifier, and you see the classical formula that we get back here from that. Okay, so this is just on this how we on this question. Hey, what is fairness on the one hand, coming from a philosophical argumentation, but then not staying there, but trying to operationalize that, creating the concepts that we need for that, and then this creates the basis then of design a system that is fair according to what we have defined before as fairness, which might be very case-specific and which depends on those choices. And this brings me to the last slide here. So this is kind of the wrap-up here. Basis and fairness are moral concepts, not technical ones. So this is it's an obvious statement. But if it's so obvious, then we need to dig into that, even if you're coming from technology. So what is fair in a given context must be specified, and I have this luck to work closely together with a philosopher since 5 years. I have learned so much, and what I have learned in particular is that there is a language of speaking about it. There is more than 20 centuries of human culture and discussion and of speaking about that, and we should profit of that. We should expect different opinions in an open society as we are, so we need some kind of agreements. This is also part of the game. So we have seen that there are three basic philosophical or legal concepts: socio-demographic groups, the principle of equality, justified inequality. We also seen when we want to build systems that are fair, we need some kind of operationalization, and this should not be arbitrary. So this is really there are a lot of computer science technical papers out there where the choice that is made in terms of what do we exactly mean with fairness and why would we mean with that, and how would we explain someone that this exactly in this context is fair versus something other is unfair. This is, I mean, to a large extent missing, and this is a responsibility of all of us to think about that. So we need an operationalization. For that we need technical concepts, and this utility function is one of the concepts that we have seen to be necessary, and the concept of justifiers is also something that we needed to kind of introduce formally as well, and combine that with the math that otherwise was already around. And then still, the last point, we need, in an implementation, we need solutions that still fulfill the basic reason why this system has been built in the first place. So there's a reason why people build AI around HR processes, right? And just ignoring that and say, well, you know what, now you should make the world a better place, and this is your new task would not lead to anything. So this is a technical challenge, how to solve that. I would love to have a bit more time to speak about what we found here useful, but I'll skip that for the moment. Just a few selected papers of the last years. I think the slides will be distributed, so you don't need to maybe to photograph that. But there is a website, fairai.ch, that you can know by heart. Check that up there as well. Okay, thanks so much for your attention.
Many thank you, Christoph. So we have time not only for one question. So, yeah.
Yeah, so I'm not sure if you have a lot to say about my question, but so you talked a lot about the work of trying to translate some idea of fairness into a metric that is hopefully well aligned with that idea. And I kind of wonder, okay, I'm sort of the opinion that these metrics are kind of good then at saying when something is not fair, but then trying to optimize to, those metrics is not necessarily going to make something that's aligned with the idea of fairness that you had in the beginning. And I'm sort of wondering if you have looked at or thought about sort of downstream implemented fair models and done the sort of qualitative analysis to say, like, if we are trying to improve according to this metric, are we actually improving according to the idea of fairness that we initially sort of set out to operationalize?
Well, what we suggest is really to think about that very carefully at the very beginning. How do we think a fair outcome would look like, and why? And if we build something and the outcome is puzzling to us, then we have a contradiction between what we have decided at the beginning at the end. This might happen, of course. Then we would need to adapt that. But those kind of contradictions come most probably, and in a lot of cases you can see that they come from not being very serious at the beginning. Yeah, so just start with something that is maybe easiest to implement, and then being surprised that what comes out does not really match your moral intuitions. So think about that beforehand, before you build that stuff, and otherwise you will be surprised by the results.